Okay, I'm doing this video as a response to someone's comment, a question on YouTube about they're trying to make a body and they're having some problems. And the problems he's having are some of the exact same problems I've mentioned in some of my videos. And just actually in the last week, I've kind of hopefully got things under control and figured things out. So for you, buddy, this is what you're having problems with and possible solutions for you. Now, your first one you mentioned was the bubble in the roof. You showed a picture and it's got the bubble in the roof, and that it most definitely is from air trapped on top here. Now, I started out by roughing up the surface a little bit, because if you have a little bit of rough surface, you can get that air to escape as it's forming. Problem is, if you roughed it up too much, you'll see that in your plastic that you form on the mold, and that will cause your plastic to have a texture to it. So you got to be careful. Then the other thing I have been doing is heating up the mold, and then sometimes I run a heat gun as it's forming on it to keep that plastic, because what's going on is your plastic is cooling. It's drooping. It's drooping in the tray as it, or the frame, as it hits that plastic. It cools right there real quick, and then as everything finally comes together and you suck the air out, this spot's so cold already that it can't form to the body mold. It's done. It's crystallized, and so now the plastic won't. It's hardened enough that it won't form to the mold and remove that air out of there with the vacuum applied. So what we've finally done, this is a bad one. We're using this as a protection for the mold. We've got one right here that you can see. No bubble. Perfect. How did we do that? Well, it is heat. Heat. Now, with our temp gun, the oven area where it heats the plastic is usually about 800 some degrees, a little less than that. So it gets heated up back in there, and it takes about, depending on the mold and the sheet of plastic, about roughly 30 to 38 seconds, all dependent on stuff. And it comes out and it hits the mold and it cools and it gives this bubble. But what we're doing is that plastic comes out at 400 about degrees Fahrenheit. This is all Fahrenheit out of that area. And the mold normally, when we were heating it up, was only about 120 to 180 degrees. Just wasn't enough. Even with doing the heat gun trick on top of the plastic as it's starting to form, wasn't enough. So we're now heating it up with the heat gun ahead of time up to closer to 240 to 280 degrees Fahrenheit. And then we don't have any problem. That's what made that. That's what did it. So that brings up another problem, though. The problem being is that if your mold material can't handle the heat, it will degrade very quickly. Another possible solution for you to get over it is to drill a small, tiny hole in the top of your mold. The problem with that is that might be the only area that really forms in a close radius to that hole. So that means only there it'll come down nice and neat, but you'll have a donut shape, around it, and you won't get any more air sucked out because it's already too cold. So I kind of don't recommend that. I recommend getting the heat up. Now, traditionally, a lot of molds back in the day for RC stuff were made of wood or plaster. But if they did it right, they were done like these Bolink molds. And this is an epoxy resin. I've mentioned it in a few other videos. It's epoxy resin with aluminum powder in it. It helps retain and handles the heat much better than wood and plaster. So you only get a limited amount of runs out of plaster ones before they'll probably degrade, chip, fall apart. You have to do repairs, and it may not be worth it. Wood will dry out and it'll split and crack, and then you got to fill in all those splits. I know for a fact that a lot of Dom's bodies back in the 80s were made of wood bucks or molds, and a lot of those have had to be patched up, and so they're not in the best of shape. I don't know why, but Bolink did them the right way from the beginning and did them of an aluminum sort of material, and they hold up over time much better. I have a reproduction here of the JRX-T body. That also is a more modern epoxy resin aluminum fill, so that is much better to hold up to the heat. Your other issue you were mentioning was the webbing, and I couldn't get your picture to load quite correctly there, and I'm going to assume you're getting webbing in corners. That's typical. You can't see it in this one because I've removed them, but I had a wooden block there, a wooden block there, there was another one over there, there was another one there, and another one there. And you can see how we did a little bit of webbing there, but it's underneath the cut line, so it's not real bad on that one. This one that we got better, you can see there's next to no webbing, even though it's, you know, it's out of the cut line and everything. And there's a couple things to do. It's not just the web catchers that are going to be your thing you do. Before you do web catchers, the key is to have the temperature correct on your plastic. If your plastic is coming out of the oven too hot, it's going to bunch up. The other thing is, if your vacuum is too quick, it can bunch up. If it doesn't have enough time to evacuate air out of other places first, before it gets down to this corner, it's going to have a whole bunch of extra plastic it doesn't know what to do with, you know, as it's sucking stuff out, and it's all going to bunch up right there. In one of our videos, we mentioned we've modified our machine. We've put a valve that controls the airflow. Instead of having it wide open, I think it may have been on this mold or actually the other one we ran the same day. I witnessed it firsthand. Wide open, bad webbing. About 50%, no webbing. And that was using the temperature all the same for the plastic. The plastic came out of the oven, same amount of timing back in the oven. I shouldn't say really temperature, but the amount of time back in the oven. Timing was the same. So if you get your timing and temperature that the plastic comes out at down, that can help reduce the webbing. That valve, how quickly it evacuates the air, that can adjust it. That can affect the webbing. And then the other thing is, of course, if you've tried all that, is to add the blocks in to catch. And the key kind of on this is the corners right here, it's webbing out this way. You want to pull the plastic the opposite direction. So you want to pull it, that's, you know, away. And since this one didn't really matter because this is all waste area, we just put blocks here just to pull it in a general direction. It didn't really matter. Now, here on the corner, since we've got a lot more features of the body, we put one here and we put one here, and that's to pull the webbing these two directions away from where it was bunching up. So hopefully that helps you. I'll show you this other mold. You can get an example better maybe visually. Look at this one. See? Pulling it away. Now this was done by a different place that ran these for us originally. That is how they did it with some foam blocks. But over time, the adhesive on this degrades and they come off. So it's not the best solution. But you can see we still get a little bit of webbing, but it's now more acceptable. Yeah, so get those blocks set out to the side, and you may also have to adjust the position of the blocks depending on how hot and how much time you've got on the plastic. You may have to move these blocks closer or farther away to get rid of the webbing. If you see that the blocks have the plastic forming around it really nice, there's not more of a dome shape to it. If it's like really, really nice forming to those blocks, and there's none of this sort of stuff happening there, you know, to it, the chances are your plastic's coming out too hot. Might be part of the problem. You know, it's been back there too long. So if you can't change that, you may want to move the block closer to the mold so that it's pulling it away, because everything's stretching out still because it's so hot, so it's going to stay over here. And then you're getting more material pulled from other places to go over this, and you want it to pull from over here, not from around here. So if you can adjust that position, that can do it. Also, once again, how long it's back in the oven can help you. There's a lot to this. You'll probably get a little frustrated with stuff, and it can be discouraging, but it just play with things and see what you get. The size of the block can be a big thing. We've got some molds that the web catcher block done by other is goes the whole length practically back here, and that's to pull a whole lot of material this direction. You could do something like that. You're just going to have to play around with the timing that you heat up the plastic for, and maybe put in some web catchers. That's about the best I can tell you. And also, as I was saying, the vacuum, how much vacuum you've got applied to it. I assume you're probably running a shop vac, not a tank that you're releasing the vacuum pressure on. So watch for that. If there's a way you can put in a valve in your vacuum thing, that might be something to do. Otherwise, you're probably going to have to go the amount of time that the plastic's in the oven or the web catcher route, and you're just going to have to play around with it a bit until you get it. And don't think one is going to do it. How much with one of our body? I think we had 6 around here to try and get them all, just using the blocks we had on hand. We probably could have done it with some bigger blocks, but we had to put a ring around here to get this plastic down and everything. It's a game. You got to play it and see which thing is going to fix it for you. So good luck.